All right, this is Algebra 2, Lesson 70. That is page 495 in your books. Make sure you open it there. Every day I'll have a different question for you to answer. This is just optional. You don't have to do it. It will be under your homework assignment, but you have to read down here on the description box to see what the question is. But every day there's going to be a new question just to keep you entertained. Here we're solving radical equations. So multiplication and division, they undo each other. Addition, subtraction, they undo each other. Same thing here with radicals. So square roots and squared, they cancel each other out. So to get rid of a square root here, because we're trying to find what x is. Here x is underneath the radical. We have to get rid of the radical. That means we have to square root it. They cancel each other out. But what you do to one side, you have to apply to the other side. So then this cancels out this. You are left with x minus 5 is equal to 14 squared. That is 196. Now, you're getting x by itself. You're adding 5 to both sides. And x will be equal to 201. There's a way to check your answers, and the more difficult it becomes, you will have to check your answers because you can find what x is, but it could be a no solution problem. So here to check it, is the square root of x minus 5, so it's 201 minus 5 should equal 14. So equations, left side, right side. So 201 minus 5 is considered 196. And now we solve. The square root of 196 is 14. 14 equals 14. That means 201 is a solution for x. Next one. We have a square root here. The x is underneath the square root. So we have to think of squaring, but before we square, we have to make sure it's by itself on one side of the equal sign. So here's the equal sign. We have to make sure it's by itself. It's not by itself. There's a 3 being added into that radical, so we have to cancel out that radical. So we get 6x plus 7 is equal to 6. From this point, now we can go ahead and get rid of the radical. To get rid of the radical, you square both sides. You get 6x plus 7 is equal to 36. Now you find x. So to find x, you subtract, and then after that you get 29, and then you divide by 6, and then you get x is equal to 29 over 6. So if it's a fraction, that's fine. Now to check your answer, you go back again. You do 6 times 29 over 6 plus 7 plus 3, and that should equal your 9. So exactly like this, I just plug in what x is. So now, this cancels out. You get 29 plus 7. 29 plus 7, you end up with 36 plus 3 equals 9. This is 6 plus 3 equals 9. And you get 9 is equal to 9, so that means that solution works for x. Next one, we have cube root. So just like the square root is canceled out by squared, the cube root is canceled out by a cube. Here, the root is not by itself on one side. We have to make sure we apply that rule. It has to be by itself on one side. So then, we have to move over the 6. So then we get the cube root of 4x plus 4 is equal to 6. Now we go ahead and cube root for both sides. So this cancels out this and this. We get 4x plus 4 on one side. And then 6 cubed is 216. And then from this point, you simply just solve for x. You subtract by 4. 4x equals 212. And then you divide by 4. And when you divide by 4, x is equal to 53. And that is your answer. You can check it again, but I'm not going to do it for the sake of the video. There's a time limit for this. B, we have negative 2 times the cube root of x minus 8, equals 14. Here, the root is not by itself on one side. We have to make sure we get rid of it. So that means to get the root by itself, we divide by negative 2 to both sides. Then we get the cube root of x minus 8 is equal to negative 7. From this point, now we can cube root it. It's by itself on one side. Remember equations, left side, right side. This cancels out this. You get x minus 8 is equal to, this is negative 343. It's a cube root, negative, you're multiplying 3 times, so it's going to be a negative in the end. Now, to get x by itself, you add 8 to both sides, and you get x is equal to negative 335. And to check your answer, which I did here for the last two, and it works out well. So that's a good thing. Example 3. Example 3, we have the radicals of each side. They're talking about graphing. If you were to graph each of these, that means this will be one graph, so y is equal to this equation, and then y is equal to this equation. That's two separate graphs. You can use your graphing calculator, and they'll show you, they have a picture also on your book to show you what it looks like, but we're not trying to do that. We're just trying to solve for x. Here we have a radical on each side. We can't move anything around. We can't do anything there. We're stuck there. So from this point, we have to make sure we get rid of the radicals from this. Now, to get rid of the radicals, we square root it. Keep in mind, they are the same root. If they are the same root, they easily cancel out. So that's what makes it beautiful. So this cancels out with that. And that, now we get 8x minus 15 is equal to 4x plus 5. They cancel out. Now we have an equation that we learned from Algebra 1. We get the x's together. We get this x by itself. We get 4x minus 15 equals 5. Add 15. And then 4x is equal to 20. X is equal to 5. And that's how you can solve for your answer there. B, now we have this situation here where we're not dealing with square roots, we're dealing with cube roots. That means to cancel out both sides, we have to cube root it. This root is by itself on one side. Notice that this here, the 2 is right next to it. They're multiplying into it. There's no way we can move it around because now the 2 is multiplying to this or it's dividing into that. It makes it complicated. All we can see here is we have a radical on each side. You can't do much about it. So if you can't do much about it because there's 2 radicals on each side, just get rid of the radicals. I cube root this. This cancels out this. I end up with 3x on one side. The cube here, we have to look at this as being 2 factors. There's a 2 and there's that square root. The 2 is being applied, so it's going to be 2 cubed times, this is also being applied, the cube root of this is going to be applied to x minus 1. So the cube is affecting both factors. So 2 cubed is 8. And then we get x minus 1. Because remember, 2 is still multiplying into the radical. The radical now turns into an expression. Then we use distributive property. So we get 3x is equal to 8x minus 8. Get the x by itself. I'm going to move this 3x over here. We're going to add this h over here. Again, I'm just doing this quickly. This cancels out here. Oh no, this doesn't cancel out. This cancels out and this cancels out. So 8 is equal to 5x. And to get the x by itself, you divide, and you get x is equal to 8 over 5. And that is correct. Or you can do it as a decimal, doesn't matter. On your homework, I accept either or, I'll put both answers there. The last one is why checking your answer is so important. So here we have the square root of x minus 4 is equal to negative 8. We have to solve for what x is. That means before we square root, we have to make sure it's by itself on one side. There's no radical on the other side, so we don't have to worry about squaring both sides just yet. We move this over. We have the square root of x is equal to negative 4. Now we can go ahead and square it. X is equal to positive 16. So then we have what x is, so we got it by itself. Here, we have x is equal to 16. If we go back here, if we look back at the equation and we plug it in, so we have the square root of 16, that's what x used to be, and minus 4 is equal to negative 8. This is 4 minus 4 equals negative 8. We end up with 0 equals negative 8, and here, this is not a solution. So for your answer, if this ever happens, your answer will be no solution. So that's why it's very important to check it. Next one. X plus 1 is equal to the square root of radical 2x plus 10. We have a radical by itself on one side. So to get rid of it, we can't move anything else around. We have to square both sides. But here, notice that you're squaring one side. You're also squaring the other side, but we have to see this as an expression, as a binomial now. So now we have, on this side, these two cancel out. We have 2x plus 10. This, x plus 1 squared is equal to, and I'll just do it here. x plus 1 times x plus 1. You multiply it all out, and you get, just to save your work, x squared plus 2x plus 1. From this point, you go ahead and factor. All right. From this point here, we're going to go ahead and move over the 2x. When we move over the 2x, it looks like they cancel out, you end up with x squared plus 1 is equal to 10. We can get x by itself here. We move the 1 over, x squared is equal to 9, and then we square root it. When you square root an answer, that means you get the positive or negative of whatever you're squaring. In this case here, this turns out to be a perfect root. That means you have two answers there that are possible. You have x is equal to 3 and x is equal to negative 3. And this is where you have to check it. So instead of having one answer, we have two. So to check it, we're going to do the first way, which means you have to solve it out. Get 3 plus 1 is equal to square root of 2 times 3 plus 10. You solve it out, your answer, you're going to have 4 is equal to 4. You can do that on your own time. And it works out for the x equals 3. So that's a good thing here. Now let's try the other one, negative 3. So same equation here. I'm plugging in negative 3 in place of x here. I have negative 3 plus 1 is equal to the square root of 2 times negative 3 plus 10. And when we solve it all out, I end up with negative 2 is equal to 2. This is not the correct answer. That means only one of the two works out. So that's why it's very important to check each of your work. All right, so make sure you're diligent in your homework. I miss you guys. Have a good day.